We noticed that chronic alcoholics have low glutathione levels. Glutathione is very important because it protects your cells from becoming toxic. And without glutathione, the alcohol can become very toxic. The idea was perhaps what we should do is provide them with something, either glutathione itself or something that produces glutathione. And it turns out that if you give glutathione alone, that's not effective because it is not bioavailable. That is, if you take it, it can be absorbed by the body. And so you have to give the patient a precursor of glutathione, cysteine. But even cysteine is not bioavailable because it gets destroyed in your digestive system.
It was all focused on this notion of providing the body with the raw materials to maintain the levels of glutathione in order to help detoxify all sorts of toxic situations or agents or whatever that you might run into. And it was just such an interesting concept, of a really positiveness to it, to bolster the body's own ability to protect itself. And so that was just fundamentally interesting. We hit upon this idea of using sugars in conjunction with the amino acid cysteine, which is the backbone. And ribose was one of the sugars that we tested. And the combination of those two obviously became ribosine.
Here's how ribosine works. Since cysteine is not bioavailable when taken by mouth, meaning it is destroyed before getting to the cell, we chemically combine cysteine with ribose, a natural sugar present in your body, to produce a new compound called ribosine, which is now stable and can be taken by mouth. Once it reaches the cell, ribosine is converted back to cysteine and ribose by a process known as hydrolysis, which requires water. Now this cysteine can combine with glutamic acid, which is already present in the cell. That compound, known as glutamic acid cysteine, then combines with glycine, another amino acid present in cells. The final result is glutathione, the body's master antioxidant.